Welcome back to Learning with me, Ms. Killen here at MPB. We're still in Unit 11, which is our statistics with two variables. Today we are looking at our lesson 3. So it is function, models, and scatter plots. We are looking at finding the line of best fit when classifying and interpreting scatter plots. We are looking at SID 6AC and 7. So let's jump on in. Now we have quantitative data involving two variables. And we have those scatter plots. Scatter plots of data show a graphical representation of the relationships between two quantitative variables. They do not follow an exact path, but a scatter plot graph can be described as linear, graphic, it has a quadratic graphic, or it could have an exponential graphic. And Ms. Killen misspelt quadratic. We all know quadratic is this. So make sure you always look at your spelling. So here we go. Look at the following and describe what type of relationship may be represented by the scatter plot. So obviously we're seeing these scatter plots and they're not an exact line or an exact parabola or an exact curve, but it is shown like those different equations. So if I looked at this one, I could draw a straight line. You know Ms. Killen can't draw a straight line. So we could say that this is linear scatter plot. Now let's look at the bottom one. Obviously it's not an exact parabola, but it does follow the parabola's way. So we could say this is quadratic. And then obviously this one would follow similar to our exponential. So even though, like we said, it does not follow an exact path of these linear, quadratic, or exponential, we can see the ways that they are following the curve or the straight line. All right, so let's see. It says you can describe scatter plots as positive or negative. Now, let's look at this linear. We are going from the top left to the bottom right, so we could say that this is positive or negative. You're right, it's going to be negative. And then, obviously, our quadratic, that's not how we look at it, positive or negative, but we can see our exponential as positive or negative, and we know that since it's going slowly and then increasing, this is going to be a positive exponential. So then let's see what else we have. New vocabulary, correlation. Now, we're going to see correlation again this chapter, but I do want to introduce it and give a little bit of reference to it right now. So it says that correlation is defined as the statistical association between two variables, meaning what? A correlation exists between two variables when one of them is related to the other one in some way. So it doesn't necessarily cause the other way to happen, but there's a relationship between them, and there's a real close relationship between them. So let's see. If a data set has a positive correlation, it is trending in an increased pattern. Well, obviously, we can increase not having exponents, but we can show an increase when we're going up. So we would see something along these lines. So that would be considered an increase in our trend. All right. So next, if a data set has a negative correlation, it is trending in the not increase, but the decreasing. So we are looking at decreasing. So this would look more along like this in a decreasing way. So that's what our correlation is showing us, either positive correlation or negative correlation. All right, if a data set has no correlation whatsoever, it means that changes in one variable do not predict the changes in the other variable, such as shoe size and intelligence. You can have the biggest feet in the world, that does not mean anything about your intelligence. Favorite color versus annual income. Your favorite color could be purple and you could still not have any money whatsoever. So it does not matter. The next one says the number of pets versus your phone battery percentages. Now, we are all sitting here on 2% and we have 100 million pets. So obviously, these two do not predict anything about the other. So that's what it means when we have no correlation whatsoever. Now, our regression line is a straight line that best fits the data in a scatter plot like those that I drew. It represents the relationship between the two variables by minimizing the distance, typically the squared vertical distance, between the line and each data point. So you're looking at the line that comes down or the line that goes up to show the way of the scatter plot, and then the distance from those different points to that line. All right, it says there are 4 regressions that we look at. We look at a linear regression, a quadratic regression, an exponential, and a cubic regression. All right, so here is our linear regression. Obviously, since it's linear, we're still looking at y equals mx plus b. Our use is when data forms a straight line pattern, not necessarily a complete straight line, but a straight line pattern. Example, predicting costs based on hours worked. So here is one good example here on the left. This is our line of regression, and then here is our different points on our scattered plot. And here is maybe another larger based scattered plot with more points, and then we can still see this line of best fit. All right. Over a 10-month period, Corinth High School collected data about the Beta Club's TikTok post each month. The data is summarized below. So here we go. We have a graph and we have our table. So in our first month, it says we have 40, the second month, 60, the third, the fourth, and so on. So what we need to do now is see, is this linear or is this exponential? So the wonderful thing about the tools that we have in our toolbox is we can take these scatter plots, we can take this table, we can plug them in and let all of those tools give us the information back. So the first thing we're going to do is we are going to pull up our Desmos. So I want everybody to pull up their Desmos. And the next thing we're going to do is we are going to put in our table that we had. So we're going to press the plus button and we're going to hit table. Now we're going to put this table that they gave us about the information on their TikTok post. So we're going to put our X's in first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our months. Now let's go back up and put our post amounts. So for our first month, we had 40. Second month, we had 60. Third, 110. Fourth, 150. Fifth, 350. Sixth, 760. Our seventh, we had, I missed one, sorry. What we did is we missed our 6th month, which is 520. There we go. Our 7th month is 760. Our 8th month is 1100. 9th month is 1550. And our 10th month is 1680. So I have graphed our table. So what I'm going to do is I'm going to have to look at this, and here we go. When I am looking at this, obviously my numbers are so small, I'm having to look further and further up. So by just looking at my Desmos, I can't tell if that is linear, I can't tell if that is exponential. So what I'm going to do is I'm going to ask my Desmos, what is it? So when I am here, I am going to say, I'm going to look for my linear regression. So the first thing I'm going to do is put y sub 1. Now, we need to tell our Desmos that we are looking at a range of things. So we're going to go to this ABC button. We're going to go to the 1, 2, 3 button. 1, 2, 3 button. Under the 1, 2, 3 button. And we are looking at this little squiggle right under our Z. There we go. So we go to the ABC button, and right under the Z button is that little squiggle that tells us the range that we're looking for. So let's go back to this. So obviously, if we're looking for linear, it's y equals mx plus b. So I'm going to do y sub 1, the range of m, which is here, And then we have our x sub 1 plus, then we're going to put our b. And it's telling us everything that we need to know about our line or our scatter plot. It tells us what our b is, and it tells us what our m is. Now, Ms. Killen, what if we look and it's not linear? Good question. Let's go ahead and put in that y equals ab to the x and see the information we get about exponential. So once we wrote all this information down, we're going to put in our information for our exponential, which is y sub 1. Going to go back to that squiggle little line. Then we're going to put a times, and then we're going to put b to the x sub 1. And it gives us the information about our exponents. We have what our a variable is and what our v variable is. We want to make sure that we're writing all this information down. So now that we're looking at this, let's see if we can scroll and see a little bit more of this. So when I scroll and look a little bit more, I see my exponential has a little bit more close distance than that linear did. So let's go back and look to see if this is what we're looking for. So here was what we put in Desmos. This is the information for the linear part that we got for Desmos. And then this is about what we saw. So maybe, maybe not. So let's look at our exponential. Ms. Killen could be wrong. It may be linear. So let's look at the exponential a little bit closer. So my exponential, obviously my graph, the information that I got about my exponential, and then here is that graph that we shown. So if I wanted to say which line is this, is it linear or is it exponential, I would have to say what? I'm thinking it's a lot more exponential than it was that linear, because that linear did not really get as close as some of these exponential points, or this exponential line got to some of these points. So I would say that this would be exponential. All right, so if we use the linear regression equation, what would be the prediction for the 12th month? So obviously we take that and we would use y equals 1.94.788x minus 439.333. Now, Ms. Killen, where did we get those points again? This is what we got when we looked at that linear regression. So let's go back and look. This is what we got from those linear 194.778 and negative 4.39.333. So this is what we are using. So then it says for the 12th month. What I'm going to do is I'm going to plug in for x. I'm going to put 12. Now, this is a calculator skill. All I'm going to do is plug this into my calculator and come up with my answer for 12. So what would be my prediction for 12? So I plug this in. I have 194.788 parentheses 12, close parentheses, minus 439.333, and I get, obviously I can't have a portion of a TikTok, so I would say that it is roughly 1898. All right, so now it says what is the prediction number for 12 using our exponential. If we go back and look what information we got about our exponential function, we had y equals 78.6077 times 1.37171 to the x. So now I'm going to make this 12 and plug this into my calculator. So I have 78.6077 times 1.37171, my exponential key, and I'm going to put a 12, and I get, Obviously, we can't have a portion of a tick-tock, so it's going to be roughly. So this is how we are looking at these linear regressions and these exponential regressions. So then the bottom asks us, what is the best equation to use? Obviously, it's going to be our exponential. So our exponential is really the one that is best fit for this situation. Miss Isabel wants her class to show the relationship between the number of hours her students slept and the scores that they made on their morning math test. All 10 students' scores are on the table along with their scores, along with how long they slept, and their scores are out of 100. So this is her students, this is the hours they slept, and this is their scores. So what we want to do right now, let's go ahead and label this graph and let's graph our points. So I'm going to have, let's put 0, and we're going to put hours slept on the bottom, and then I'm going to have scores here, and I'm going to have sleep versus scores as my title, remembering we always have a title. So then I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the scores start at 65, so I'm going to put a little line here showing that I am missing some numbers, and I'm going to start with 65, 70, 75, 80, 85, 90, 95, 100. So now let's go ahead and graph them. Let's graph them in green. So for 4 hours, we had a 65. So 4 hours, we had a 65. 5 hours, we had a 70. 6 hours, we had a 75. And 6 hours, we had a 78. So we're going to put it halfway between. 7 hours, we had 80 and 82. So we had 80 and 82. 8 hours, we had 85 and 88. So we had 85 and 88. 9 hours, we had a 90. And 10 hours, we had a 93. All right, so this is what my table looks like when we graph our scatter plot. So what I am just going to roughly put, maybe we have a line of best fit that looks something similar to that. So another way that we could double check ourselves is we could take this table, we could plug it into Desmos, we could plug it into our calculator and have it graph the scatter plot. So since we've done that, let's answer some questions. In the graph, does the scatter plot show a positive or negative correlation? Well, obviously it's what? I would say it's positive. Why do I say it's positive? Well, the more hours they slept, the more that their scores went up. All right, so let's look at the next one. It says, based on the scatter plot, predict the quiz score for the student who slept 6.5 hours. So if we keep with this trend, and I go over here to 6.5 and go up near my, I'm going to say it's going to be around there. So maybe 78, 79, maybe between 78 and 79 degree, your grade. So then, let's look at our next one. It says, what would the linear regression for this be? Now, this is when you go to your Desmos, or this is when you go to your calculator and you put this in, and then you pull up that line of regression. Obviously, it is linear, so you're going to do that y sub 1, your little squiggle, and then your mx plus b. And so when you plug that in, what do you get? I got y equals 4.8x plus 47. We've got to make sure that we're getting comfortable taking something we've done in our class lesson and then doing this with ourselves, guys, because I'm not going to be there on test, or your facilitator's not going to be there on your big assessment. So we've got to make sure that we're taking these lessons that we're learning and being able to put them into practice. So there you go. We have 4.8x plus 47. So then let's see what else it asks. So obviously this is a little bit better drawn of what we did in Desmos. We put our table in, we found what Desmos told us about the 4.8 and the 47. So obviously we were right with positive, and it was linear. So then it says, how do you predict the score 78.20 using this formula? So we take what we know. We are looking at y equals the mx plus b. So we take the y equals 4.8x plus 47. But now instead of y, we are going to use what our grade is, which is 78.20. So what I'm doing is I've found what my y is. I'm just trying to get x by itself. We do that with opposite operations. So I'm subtracting 47 on both sides, and I get, calculator skill, 78.20 minus 47, and I get 31.20 equals 4.8x. Divide by that 4.8 on both sides. And so what does my x equal? So I'm going to divide by 4.8, and I get 6.5. So we were right. That grade that we had for 6.5 hours of sleep was between 78 and 79. So we were correct. So this is what all this means. The y is the predicted score. The x is the number of hours of sleep. The m is my slope. And obviously that b is that y-intercept like it's been forever. All right? So fit, which would be your line of best fit for your hours of sleep versus your score. Obviously, we're using that linear regression, and our m was our 4.8, and our b was our 47. All right, so we don't want to forget, what do we now know about positive and negative correlation? Remember, positive correlation is going to see some type of increase. Negative correlation is going to be some type of decrease. Okay, what did we learn about putting data in our calculator or Desmos? Calculator and Desmos are the same that we're talking about here. Remember, we're putting in that table, then we're going down there and putting that y sub 1, that little cursor thing, and then we're putting that m and that x of 1 plus our b if we're looking for our linear, and if not, if we're looking for our exponential, we're putting that exponential formula in. We want to make sure that we are remembering what our different formulas for our functions are. Good job. I want to tell you that you're doing awesome. We're almost to the end of Unit 8. Don't worry, we're almost there. You're going to get it, I promise you. And as always, this is Miss Killen, and have a great day.